In this video, we're going to work some problems involving finding the components of vectors and summing vectors. All of these problems are going to be coplanar, and we're going to use Cartesian vector components, so the I hat and j hat, to solve the problems. Doing it this way is going to make it much faster than the previous problems that we did graphically. That's why we're going to do multiple problems in this one video. Okay, determine the x and y components of the 800-pound force. Okay, so we want the component in the x direction and the component in the y direction. So Fx is equal to 800 opposite over hypotenuse sine of 40. The 514.2. Okay, and then Fy is equal to the adjacent over hypotenuse, 800 cosine 40, but it's going to be negative because it's in the negative y direction. Minus 612.8. Okay, resolve F1 and F2 into their x and y components, and then determine the magnitude of the resultant force in this direction measured counterclockwise from the positive x-axis. Okay, so let's resolve F1 and F2 into their components first. So F1, this is a vector, so we want to bold it or put this arrow, is equal to what? This is 30, this is Fx, this is Fy. Both are in the positive direction, right? This is F1y, this is F1x. So F1x is F1 opposite over hypotenuse, F1 sine of 30. So 400 sine of 30, that's I hat, right? And then F1y is F1 cosine of 30, adjacent over hypotenuse, and they're both positive. Okay. So sine 30, 200. All right. Now, cosine 30, 346.4. Okay, that's F1. Now, F2 is what? So this is F2y, and this is F2x. I mean, we could draw it, this is 45 degrees, but we could draw it like this is F2x, this is F2y. We could draw it like that as well. And so F2y is going to be negative, F2x is going to be positive. So we've got 250, and then adjacent over hypotenuse, cosine of 45, I hat, minus 250 sine of 45, j hat. Okay, so 250 times cosine of 45, 176.8. Okay, and then this is going to be the same number because sine of 45 and cosine of 45 are the same value. Okay, so we've got F1 and F2. Determine the magnitude of the resultant force in this direction measured counterclockwise from the positive x-axis. So what is F1 plus F2? Well, to add vectors in component form like this, we just add the corresponding I hat and j hat components. So we've got 200 plus 176.8 I hat, and then plus 346.4 minus 176.8 j hat. Okay, so 200 plus 176.8, 376.8. Okay, and then 346.4 minus 176.8, 169.6. Okay, so that's F1 plus F2. Now it acts for the magnitude. So the magnitude is just this squared, the square root of this square plus this square. Okay. So this squared plus this squared (413.2). Newtons. Okay. That's the magnitude of the resultant force. Now, the resultant force has a component in the I hat and then a component in the j hat. All right, so we can kind of, it's like this. I don't know where exactly it's oriented, but it's somewhere in this quadrant. So to get this theta, we can just say theta is equal to, and just look, so put just the magnitude of this divided by the magnitude of this, opposite over adjacent. So theta is equal to inverse tangent so inverse 169.6 divided by 376.8. 24.2. Measured counterclockwise from the positive x-axis. That's it. Okay, determine the magnitude and direction measured counterclockwise from the positive x-axis of the resultant force of the three forces acting on the ring A. Take F1 is equal to 500 newtons and theta is equal to 20 degrees. Okay, so we just need to resolve these force vectors into components, and then we can add them easily. Let's do this force vector first, and let's use the slope triangle method, because that's pretty easy to find components with the slope triangle. So this has it's negative component in the x and a positive component in the y. Okay, so you got minus 600, and then in the x, 4 over 5. Right, 4 over 5. That's I hat. Plus, now in the positive y, 600 times 3 over 5 j hat. So 480 minus okay, let's do this 400 Newton vector. That's in positive x and positive y. So 400 adjacent over hypotenuse cosine 30 I hat plus 400 sine 30 j hat. $346.4. $200. Okay, F1 is 500 newtons and theta is 20. So this is 20 degrees. And F1 is in positive x and positive y. So we've got 500 what? In the x opposite over hypotenuse. 500 sine of 20 I hat, and then plus 500, and then cosine of 20 j hat. So $171. $469.8. Okay, now the resultant force, let's just add these vectors up. So minus 480 plus 346.4 plus 171. Okay, now 360 plus 200 plus 469.8. Okay, minus 480 okay, 37.4. Okay. $1029.8. Okay, now it wants the magnitude of this, so we're going to take the square root of this squared plus this squared. Okay, 1030.5. That's in newtons, and we could say that this is 1.03 kilonewtons. Okay, now it also wants to know the direction of this measured counterclockwise from the positive x-axis. And so we're using arctangent of Fy over Fx, or it's arctangent of whatever, of any components that you pick. Determining the angles, you do this kind of manually. In other words, you look at your vector. This is the resultant vector, and so you can see it's positive I, positive j. All right, and so it's a lot more in the j than in the I. So if you want a better visual, you can say, so it goes, you know, a good bit in the y, and then a little bit in the I. So that's the resultant, something like that, if you want to get a visual. Okay, it's asking for this angle here. All right, so you can It wants that angle. So we arctangent of this over this. And don't put any negatives. You're just putting magnitude. So theta is equal to tangent minus 1 of the y over the x. So 1029.8 over 37.4. Okay, so 1029.8 divided by 37.4, 87.9. Three forces act on the bracket. Determine the magnitude and direction theta of F2 so that the resultant force is directed along the positive U axis and has a magnitude of 50 pounds. Okay, so the resultant force is going to be here. We'll call this FR. And then, so we're given FR. FR is equal to, because we're given the magnitude of FR and we're given its direction. So it's, as far as the X and Y components, it's 50 cosine of 25, and it's positive in the X. Okay, and then it's minus in the Y, it's 50 sine of 25. Well, this is I hat. Minus 50 okay, so $45.3 okay, now 21.1. Okay, now what is F1? F1's easy. That's just 80 I hat. All right, now what is F2? We can use this slope triangle, so it's positive X and positive Y. So we've got 52 times 5 over 13 I hat plus 52 times J hat. Okay, this is so 20 I hat plus 48 J hat, okay? Wait, that's F3. That's F3. So we can say that the vector sum of F1 plus F2 plus F3 is equal to FR. So, okay. Well, first of all, these are vectors. Okay. F1 plus F2 plus F3 is equal to FR. So we want to solve for F2. So F2, and we can do this, we can just say, because the algebra of vector sums is just like regular addition and subtraction, even with equations. So F2 is equal to FR minus F1 minus F2, or no, F3. Okay. So just go do this with the components. So FR 45.3 minus 80 minus 20. I had. Okay, we had FR minus 80 minus 20. That's right, okay? Let me make sure I'm doing this right. So now we put FR again, minus F1, and then minus, which is 0, then minus F3. Okay? So we've got 45.3 minus 80 minus 20, minus 54.7. Okay, minus 69.1. So this is F2. It's going to be in the negative X and negative Y, so it's going to be somewhere in this direction. And that might seem counterintuitive, but the idea is F2 and F1 create a magnitude that's greater than 50, right? We're trying to get a magnitude of 50. And F2 and F1, so if we just add F2 and F1, it's something like this, greater than 50. We need to pull back on this. We need to pull in this direction, and we need to pull it down, right? We need to pull this down. F2 needs to pull this down, and it also needs to pull back because it needs to decrease its magnitude, you see? So that's why F2 is going to be somewhere in this direction. Okay, so how do we determine theta? Right, we're looking for this angle. Well, what we do is we find this angle alpha, and then just add 90 minus 25 to it, because we know that this here is 90 minus 25, right? This is 65 degrees. Okay, so this is the alpha is equal to arc tangent of opposite over adjacent. So it's just put the magnitudes, so 54.7 over, and then this is 69.1. So we've got 38.3. Now just add 65 to that, and we get theta. 103.4. Okay. If the magnitude of the resultant force acting on the bracket is to be 450 newtons directed along the positive u-axis, determine the magnitude of F1 in its direction psi. So similar to the last problem, the magnitude of the resultant force acting on the bracket is to be 450 newtons in this direction. So they give us the resultant. We'll call this FR. Okay, so let's write out FR. FR is what? 450 cosine 30, and that's positive, and then positive J, positive Y, 450 sine 30. Okay, so cosine 30, 389.7 I hat plus 225. Okay, we also know what? We know that F2 is equal to 200 I hat. Okay, now we know that F3 is equal to, it's in the positive x direction, and we can use that slope triangle, so 260 times 5 over 13 I hat, and then it's in the minus j direction, 260 times 12 over 13 j hat. Okay? So 260 times 5 divided by 13 is 100. Okay, minus, and then we've got 260 times 12, it's 240. Okay, and it's telling us that F1 plus F2 plus F3 is equal to FR. So, well, okay, these are vectors. You need to specify that these are vectors. I'm messing that up. That's a big mistake to do that. You want to bold these or put them as vectors, or the arrow. So, okay, we know that F1, the vector sum of F1 plus F2 plus F3 is equal to FR. And then we know that we can solve for F1 just like a regular equation when you're doing addition and subtraction. So we can say that F1 is equal to FR minus F2 minus F3. Okay, so F1 is equal to, and if we, so let's plug in the I hat components. So 389.7 minus 200 minus 100. Okay, plus, now the y components, it's 225 and then minus 240. So it's going to be plus 240. You see? You want to get that right. So like it's FR minus F2, which is 0. So FR, 225, and then minus F3. So it's minus minus. So F1 is equal to 389.7 minus 200 minus, okay, 89. All right, now 225 plus 240 plus, okay, that's F1. It's in the positive I and positive J. And this makes sense because if we add F2 and F3, so we've got something, you know, I guess like that. So to get to, the resultant's going to be FR. So F1 needs to be pulling up. It needs to pull this around to this direction. So just looking at this, I imagine this size is going to be pretty small because it really needs to pull. Yeah, and it is. Look, because the J is going to be is big, right? It goes a lot in the J, a small amount in the I. So, okay, the magnitude of F1, and you really want to write, I really messed that up in this video, not putting these arrows. You really want to specify what's a vector and what's not a vector. Okay, so let's get the square root of this squared plus this squared. So 89.7 squared plus so 89.7 squared plus 465 squared. $473.6. That's newtons. So that's the magnitude of F1. And so I guess it also needs to, I don't know what the magnitude of this vector is, the resultant of F2 plus F3, but if that magnitude is less than 473.6, then this F1 will need to pull that around and extend it. Okay, so, but, okay, what is this psi? That's just going to be, we've got the y component of F1, we've got the x component of x1. So arc tangent of opposite over adjacent. Psi is arc tangent of, and just put the magnitude. So opposite 89.7 over adjacent 465. So arc tangent 89.7 divided by 465. 10.9. So yeah, it is pretty small, like I was thinking. Okay.